is the domain. So I'm going to write out the fraction in there. I'm going to put it in minus a half. Oh, this is red. Oh, you know what? So it's really not that special, but I just wrote in red, okay? So what is the domain in this case? The domain is a collection of values of x, where the function value will be a real number. So in this case, x can be any value, except x cannot be negative half, and x cannot be 1. Because if x is equal to negative half, then the denominator becomes 0, and f of x, the function value, becomes undefined, or is not a real number. Therefore, you can write it this way. Or you can write the set this way. You know what? How about this? You can write it this way too. Is equal to. You can write this. You can write x. Then say x is not half. Not half. And x is not 1. You can write it this way too. So that is the domain. So that's the natural domain. If the domain is not specified, then that will be the natural domain. Okay, so now how about example 13? Now let me put a bar here.
Oh my God.
So what is example 13 here? What is the domain here? Well, in this case, let f of x equal square root of 2x plus 1. So what is the natural domain in this case? Okay, so dom f is equal to what? Is equal to this
I gotta get
x.
in like Cosmo.
Yeah, you gotta get one of those X bars. They're great.
So where? Oh, you know what? Actually,
The
I
X
could just
bars?
put a bar there.
Yeah.
Those are
Can I
awesome.
put a
You
bar
should
there?
get one, Mom.
He was boxing yesterday. He did good. But then he garbled sore.
Yeah, you'll be sore.
I
You'll
have
be
a
sore
special
for a
keyboard
while.
here. I can put this. Oh, there we go. There we go. I can put a bar there.
I just gotta get back.
Then I can go back.
On my diet. Just
X squared 2x plus 1 is actually greater or equal to 0. I can do this. So what is that equal to? Well, that is equal to
Look how fluffy he is. One. No.
x such that x is actually greater or equal to negative half.
Okay.
And if you want to write this in interval notation, you can. This is actually equal to negative half, like this, and all the way to infinity. And if you give me the domain in this interval notation, I will accept that too. So the final answer has to be written this way or that way. It is unequal right here. Has to be simplified. Has to be solved for x. So that's the domain. So note that in this case, example 13, f of x equals square root of 2x plus 1. Note that in order to be part of the domain, 2x plus 1 must be greater or equal to 0. It could be 0. If 2x plus 1 is 0, that's okay, because square root of 0 is 0, that's good. Or 2x plus 1 must be positive. However, 2x plus 1 cannot be negative. So, for example, if x equals, let's say, minus 10, then square root of 2 times minus 10 plus 1 is minus 19. And square root of minus 19 is not a real number. Therefore, the input, minus 10, is not part of the domain. So in order to be part of the domain, part of the natural domain, well, what must be the case? 2x plus 1 must be greater or equal to 0. And then when you solve that for x, this is what you get, and that is the natural domain. Basically, if you have a fraction, the denominator cannot be 0. This is bad, right? It cannot be 0 here. This will be undefined. And then the thing is, if you have a square root, then this must be positive. If this is negative, then that will be undefined. That will not be a real number. So how about this? If it's a negative here, if it's a negative value here, then that will not be a real number. So this is not a real number. So let me put this. Not a real number. Not a real number, and therefore that will be out of domain. That will not be part of domain. So if you have a square root, the expression under the square root, which is the radicand, that is the expression under the square root must be either 0 or positive. So that's the condition right there. And then you solve, and then you get this right here. So that is the last one. Any question on this? How about example 14? Example 14? What is the natural domain? Example 14. Don, what is the domain of this function? Sorry, domain. You know what? Why did I write over there? I want to write it next to example 14. Let me write example 14 here. So what is the domain? Example 14. What is the domain? Domain is equal to the set of all the real numbers. So the domain is actually R in this case. If you look at example 14, f of x is equal to cube root of 2x plus 1. Now in that case, we have a cube root here. For cube root, can this number, can the expression or the number under the cube root be anything? Can this be negative? Can this be negative now? To keep as a real number. We want this whole thing to be a real number. In that case, what number under the cube root, or for the number under the cube root, what could it be to make the whole thing into a real number?
It cannot.
It has to be positive.
It has to be positive. It can't be an imaginary number.
Cannot be imaginary, yeah. But in this case, in our class, we are not going to consider any imaginary number input here anyway. Now, so you're saying that. So what is cube root of -1?
-1.
It's actually -1. So what is then cube root of -2? Can you simplify this? Yes, you can. This is actually the same as negative of cube root of 2. So for cube root, and that's because -1, that's because cube root of -1 is equal to cube root of -1 can actually be written as -1 cube. -1 cube is same as -1. And so that comes out as -1. So having a negative number under the cube root, it's not a problem. It's not the same as square root. Cube root is different. Therefore, under the cube root, the radicand, that is the number under the cube root, can be any number. And the whole thing will be a real number. Therefore, for example 14, the domain is the entire real number. X can be anything. And then 2x plus 1 will be anything. And then the cube root of that number will be a real number. Not a problem. Example 13 is not the same as example 14. And by the way, what happens if it's fourth root? What happens if you have, let's say, fourth root? The fourth root is going to follow the pattern of square root. And how about the fifth root? The fifth root is going to follow the pattern of a cube root. So all of these, if you know this number right here, this number right here, and this number right here, what do we call that? This number right here, and this number right here, we have a name for that. We call that the index of the radical. Index of radical. Again, that number we call this index of radical. If the index of the radical is even, then it's like a square root. If the index of the radical is an odd number, then it's like a cube. It's like a cube root. So if you have let's say a cube root of, so let's say if I give you, let's say like this on the test, I could give you this. How about let's say this? How about let me give you an example here. Let me give you an example right here. So example, I know the board could be a mess here. For example, is equal to. How about I give you this here, and this is going to be, how about this, cube root of, then this, then I give you x squared, x to the, let's say f to the, let's say 4th power, and then let's say plus 1, then have a minus, minus 3, minus 4 times the fifth root of what? Fifth root of, how about x minus 1? then times, what is it? 3x squared, and then plus 5. If I give you a function like this, it's a very ugly function, right? And then it's all the way here. Then I can ask you, what is the natural domain of this guy? What is the natural domain? This is the fifth root, by the way. The fifth root. What is the natural domain of this function f? Find natural domain of f. What would be the natural domain of this function f? Can you tell me? What is the natural domain of this function f? Can you tell me the natural domain of this function f? In this case, dom f is equal to what? Set up real numbers. There's no restriction. No matter what the x is, we have a cube root here and we have a fifth root here, and they will all be a real number. So no matter what the x is, the whole thing will be a real number, guaranteed. So nothing will go wrong for any value of real number x. So in this case, the domain of f is a set of all the real numbers. As long as x is any real number, the f of x will be a real number as well. So in this case, that is the natural domain of f. Now let's look at example 15. What is the natural domain of this function in example 15? We have 1 over square root of 2x plus 1. What is this? Is the domain of example 15 and the domain of example 13 the same or not the same?
Not the same because there's x values that will be undefined.
Right. In this case, this 2x plus 1 cannot be 0. So in this case, example 15, example 15, let me write the answer. In this case, what is the domain here? This one, the domain is going to be dom is equal to this is equal to this x, and then this, and x is what? X is what? Sorry, that's a different character. You may not. That's a secret language, okay? I think some of you will know that, but anyway, let me change that to this, and then this is now what? That's 2x. 2x plus 1 must be bigger than 0. And therefore, what? This is equal to, now we have to solve that. So that will be x, and then will be what? Will be this. And then what? Let me move that. So that will be x is going to be what? Bigger than, and then we have this right here. So let me fill in this. This is what? Negative 1 over 2. Okay, so that is the domain. That is a natural domain. That is the largest possible domain, which is called a domain. Now let's look at this. How about if I do this? Example 16, I just made a 1. Example 16.
Sorry, Professor, before you go to number 16.
What?
Could I ask you sorry, Professor, before you go to number 16, could I ask you a question?
Yes, what is it?
On the exam, if you ask a question like this, do you want us to write it both in interval notation and the set builder notation?
No. Any one notation will do. You don't have to write both.
Okay,
or
thank you.
There are many other ways too.
I
But
see. Thank
generally,
you.
when you write the domain, the set notation is the most general notation. So this is the most general, common standard notation. But if you choose to write this in interval notation, in this case it must be open half here, and then the other side must be infinity. Infinity is always open, by the way, although in math, later on, there are cases where they actually close this, but that's a special case. It's always open. So if you write it this way, that's okay too. But I think I would ask you to write this middle step here. The middle step here is a little bit important here because you know what? this is, you will soon know that I'm a very tricky guy. I don't always ask you the question in a standard way. I like to give you a sidekick. All right, that's my style. So in our class, you have to prepare to get the question in any direction. So what that means is, on the test, I could give you this. This is what I cover in class. But then on the test, you know what? I will make some of you very angry. Why is that? Because my question will be a sidekick. This is the question I will give you. How about this? Example, find a function whose natural domain is, and then this. X is now what? Is now X is now X is now what? X is now less than, let's say, 3. So if I give you a question like this, you can do this. Find the function whose natural domain is X, where X is less than 3. So how would you come up with a function? Whose natural domain is X is less than 3, not an artificial domain? That is, you can always, come up with some function. So basically, if you have, let's say, have a function like this example, f of x is equal to, let's say, how about 2x, and then let's say plus 5, and then dom f is equal to, and then this, and then it's 4, 5, 6, 7, like this. Now, if you write this one, what is the dominant function? Yeah, the dominant function are the numbers 4, 5, 6, 7. However, this domain is not a natural domain. Not a natural domain. This is a limited domain. This is not a natural domain. Okay, is that clear? It is not. It is a domain. It is a domain, but this is not a natural domain. Basically, because this x can really be more numbers than the numbers specified here. So this is like an artificial domain or a limited domain, but it's not a natural domain. So now the question is, can you come up with a function whose natural domain is x, where x is less than 3, all the numbers less than 3? Can you come up with that with that kind of domain? And so also I can also ask you this. How about this? Find the example. Find a function whose natural domain is what? Is this right here? And then I can say this. Let me write it out. X is what? Bigger than 1. And but x cannot be 2. And x cannot be, how about x cannot be 5? I can come up with a question like this. Okay, so what is the domain? Domain is a set of all the numbers which are bigger than 1, but it cannot be 5. So on a number line, basically, what would that be? That would be 1 here, so 1 here, and then this is 5 here. The domain are all the numbers between 1 and 5.
Bless you.
And all the numbers bigger than 5. So this is now the domain. So this domain is a set of all the numbers between 1 and 5, and not 5, not 1, and all the numbers bigger than 5. It's basically all the numbers which are bigger than 1, but x is not 5. So I can give you problems like this. So I can give you backwards. Now these are what I call reverse problems. That is the answer, and the questions are switched. This is like Jeopardy. Again, this is like Jeopardy. I give you the answer, and you give me the question. But these types of problems are very common. It's not my style, okay? This is not my invention. This kind of problem is very common throughout all math textbooks, throughout all math, okay? So I can give you this. So let's look at, how about first start with this. Find the function whose natural domain is this. Do you think you can do it? If you can do it, then I'll skip it. And how about this example right here? Do you think you can do it? Now, how many functions are there? Now, you don't find a function. I only ask you to find one function. How many functions are there with this kind of domain? Let me tell you, There are zillions of functions out there. All I ask you is what? All I ask you is how many functions?
Find one function that's simple.
I'm only asking one function. There are zillions of functions out there. So everybody in this class, you know what, will give me a different answer. Okay? Because there's so many functions out there. But what are the simple functions? But anyway, this example, that example, I just wrote down 2 problems here. So can you tell me? Do you think you can do these problems, or do you think I should do it, or do you want to give it a try?
Can you try one, and then maybe we can see if we're confident to try the other?
So you want me to do both of these?
Do one, and then we'll see how the class responds.
That's okay. You know what? The second one has an extra condition here. This is more interesting. You know what? Let me just do one, okay? Let me just do one, and then you can find more problems out there. So in this case here, this is what it is. Okay, solution. Solution. Now note that we want x be less than 3, right? That's what we want. Okay, so now what is that? Okay, we want x be less than 3. So if that's what we want, then let's see what is it. This is going to be this. That means minus x and then plus 3, we want this to be 0, don't we? So we want minus x plus 3, we want that to be 0. Okay, so how about therefore, let f of x is equal to, note that this must be positive, but it cannot be 0. So how about if you do this? Yeah, you can write the 3 minus x instead of x minus x plus 3, okay? So again, if you write 3 minus x, that's okay. 3 minus x same as minus x plus 3, okay? So again, that's okay. So if I give you this function right here, that will do. So how do I know that will be the solution? Because if that is a function, that will be the condition. And then if we solve for x here, that will be the condition. And then that's the domain right there. That's it, done. So this is just one of the functions out there. It only takes, this basically is almost immediate. Doesn't even take half a minute. But you have to know exactly what's going on. Now, what happens if the domain, the natural domain is x is less or equal to 3 instead of x is less than 3? Then what would it be in this case? If you have this instead of that equal sign here, then how would the solution change? In that case, minus x and the plus 3 will be bigger than 0. And in this case, well, how should you write the function? In that case, the function f of x will be what? Will be what? Will be, and then we just put this in the numerator. Minus x and then plus 3. And then that will do. Okay? Because if you have this function here, what is the domain? The domain will be this. And the equals 0 will be allowed, because this could be 0. Square of 0 is 0, that's okay. Here, and on this example, this guy right here, this minus x plus 3 is not only not under the square root, but it's also in the denominator. That's why this cannot be 0. So here must be bigger than 0. So there are little differences here, but you have to watch out. Now how about this? Now this one is x is not bigger than x minus 1 is bigger than 0. So now what I can do is, this is very simple. Let me just, this is here. This is f of x is equal to, let me just give you one function, which is an answer. F of x is equal to square root of x minus what? X minus 1. This is x is bigger than 0, cannot be 0, so let me take this back. All we have to do is put this in the denominator. X minus 5. Sorry, not 5. It should be x minus 1. And 6x, and then 6x cannot be 5. Okay, how about this? X cannot be 5. Okay, so we'll just do plus, and then put 1 over, and then x minus 5. That will do. Once you get the hang of it, it's very easy. Of course, it is easy and short if you know what to do, right? But remember, these domains can be much more complicated than this. I can actually give you like this. How about this? Example, find the function, f, find the function such that the natural function whose natural domain, not an artificial domain, but natural domain is, and then we have this, is this right here, is this. X is between 2 and 3, less than 3, and okay, the end. How about this? How about make it 8?
No.
You know what? Let me rewrite this here. 8 and X is not 7. Okay, try this. Now this won't be a little more difficult than the other ones. Actually, not. You know what? This is really not that difficult either. But it is difficult if you have never seen this kind of problems here. Okay, so you know what? I can give you all kinds of questions. All kinds of questions. I can say that X is either between 1 and 2 or between 3 and 4 or you know what? I can make this question, but anyway, once you understand, once you get the hang of it, then they're all the same, very similar. Okay, so anyway, that's one problem here. So this I'm not going to do right now. Okay, so try this, and I make sure that you study all the easier cases first. Any questions on domain, natural domain, on any of these functions here? Now the only ingredient I will be using here will be fractions. Fractions like a over something. And in this case, the denominator, of course, cannot be 0. This cannot be 0 here. And then square root. If I give you a square root here, this guy right here, of course, must be positive or 0 in order to be defined. If positive, 0 or positive. And this will be the only ingredient I'll be using. I'm not going to give you anything weird, okay? So again, my style is to use very simple ingredients to cook up a spicy problem. So that's my style. I don't like to use complicated, expensive ingredients. I use very simple ingredients, but I like to cook up interesting and spicy problems. Okay, that's my style. So here, if I give you a problem like this on domain, natural domain, I'll only be using like square roots, cube roots, and fractions. That's it. I'm not going to give you any other more difficult ingredients like exponents and log. Yeah, I can give you that too, but or trig too. But again, I'm not going to give you those right now. Okay, so they're much more interesting and spicy. But anyway, for now, I have problems with these simple ingredients. But the questions can be forever more complicated. So you have to prepare for those. Any questions here? Any questions here?
Nope.
Okay, then I think I have. This is the end of this page of this document, or do you have more? Let me see. Oh, we have more. You know what? This operation functions. Yes, you will have some problems with operation functions today, and then this one, these are all the notations here. And some of you know this. All of you know this already. So anyway, let me just point this out. Let me just make some few remarks. F times g of x, sometimes the function is written this way. So if f is a function, g is a function, sometimes we write f times g, f times this. Sometimes it is just written as fg, like this, fg of x. But written this way, same thing. Whether you have a dot in the middle or no dot, it's exactly the same thing. What does this mean? This means that this is f of x, and then times, and then g of x. Why the asterisk means times, okay? I just like to use the asterisk here because I don't have a dot in the middle. I cannot type that here on my keyboard. So I'll just write asterisk here to mean times. Now, if you look at number 5, so that is, number 3 is a straight product. That's a product. The number 3 is a product of the two functions. That's a product of two functions. So product of functions. But if you look at number 5 is not a product. Number 5 is a composition. F circle G. F circle G, how do we read that? That is now read as, let me write this down. This is now read as F compound, read, F compound, compound G of X. That's how we read it. Or we actually read this as F composition G of X. But here, F compound G of X. So F compound G of X is F circle G, so that's what it means. So when you see this right here, this right here, that's what it means. Again, it's F compound G of X. And it's called the composition. F composition G or F compound G. I think F compound G is the more common way of saying this. So F compound G. But that's called a composition of functions. Now, example 16. F of X is 2x plus 1, and G of X is x squared. So what is F plus G of X? So yeah, that one, that one, there's not much going on there. This one is simply what, equal to, this is simply equal to F of X, and then F of X, and then plus G of X. So again, not that interesting here. So what is that? That is equal to what? Is equal to F is what? 2x plus 1, and then plus 1 plus x squared. And so basically that's the end of that. Okay, so we're here. That's it. And then number 1, 2, 3, 4 is not that interesting. And then F, and then of course F over G of X. What does that mean? F over G of X simply means F of X over G of X. That's what it means. So it's not much interesting. Now what is this here? F compound G of X. This is obviously a composition. This is F of G of X. All right, and then you can get that. What is that? What is F of G of X? This is F of G of X. What is G of X? X squared. And so what is that? That is equal to 2 times this, X, and then times this, and then plus 1. So all I need to do is what? Put a square there. This is a square. And put a square here. G of X is X squared. And then if you put that into the function F, then we get 2 times X squared. Obviously that's in parentheses right there. And then so 2x squared plus 1. And so that's that right there. That's it. So then you can get that. You can get that. Oh, now this F, compound F, yeah. Can you compound the function compound by itself, by the same function? Yes, you can. So what is this here? What is example 7? Example 7 is this. Example 7 is obviously equal to F of, F is what? This is equal to F of 2x plus 1. Plus 1. So what is that? That will be equal to 2 times x, 2x plus 1, and the plus 1. So that will equal 4x, the plus 2 plus 1, which is 3. So the final answer for number 7 is 4x plus 3. And then you can also get number 8. All right, anyway, all of these should be relatively easy to you, should be reviewed. If you don't, then of course you need more practice. These are composition of functions or combining functions. Okay, combining functions, you can see all this. So now what I'm going to do, I'm going to scroll this down here. Now let's get to the problem which I like to give you, and they are this. Example 17. Example 17. Let's look at it. Example 17. Function, constant function, f of x equals 5. So if I give you a function like this, f of x equals 5, obviously when I give you a function f of x equals 5, what I really mean by this is, f of x equals 5 for all x. That's what I mean. It is a constant. This kind of function is called a constant function. It's a very simple function. It's kind of boring in some ways. Now let's look at this. Now f of x equals 5. Now evaluate f of 4. What is f of 4? Can you tell me what this is? What is f of 4? Anybody out there? Anybody out there who's not sleeping?
F of 4 is in, you say it's a constant function, but it said function x is equal to 5, so f of 4 would just equal to 4, wouldn't it?
No.
No.
No, if f of x equals 5, if that's the function, what is f of 4?
Oh, it will just be
4
equal
is
to
not
5.
4. Is it?
It'll just be
If I
5.
give a function f of x equals 5, what that means is f of x equals 5 for all x. F of x is equal to 5. What does this exactly mean? Is equal to 5. Okay, so let me write this. When I say f of x equals 5, what does it mean? It really means this. It means this. It means f of whatever is equal to 5. We have to replace x by whatever, but there is no x on the other side. So in this case, can you plug in anything here? Yes, we can put anything. So if you want to put a 4 here, can you put in a 4 here? Can you put in a 4? Let me put this in red. Can I put in a 4 here? Yeah, we can put in a 4 here. And there's no x on the other side, so we have to replace every x by 5. Every x by 4. But the right side has no x, so there's nothing to plug in. So what is f of 4? F of 4 is 5. So what is f of 7 then?
5.
F of 7 is still 5. So then what is f of x plus 1? What is that?
5.
That's also 5.
So it's unchangeable, basically.
Yeah. Yeah, basically, when it says f of x equals 5, that means no matter what the x is, it's always 5. So if I give you this, what is f of x? That's also 5 too. It doesn't matter what the input is. So you have to understand these functions very carefully. F of x equals 5 is not the same as f of x equals 5x. It's not 5x. We have to replace every x by the same value, but on the right side, it's 5, there's no x, so there's nothing to plug in. So you just replace x by whatever, and then that's it. So this is a really boring function. Okay? So now, example 17 is a preparation for example 18. Example 18, look at that. Example 18 is this. F of x equals 5x minus 1. Okay, f of x is 5x minus 1. U of x is x cubed. X squared. G of x is x squared. H of x is 3. Oh. So we have 3 functions given. And then you know what the problem is? The problem is this. Wow. You know? The first question is this. Am I really going to give a question like this on the test? This is going to take 20 years, right? That means you have to plug in 2.227 to the function f, and then get that number, plug into the function g, and then get the result, and then plug the number to the function f. And then you have to go all the way here. Again, how long will this take? Will this problem take 20 years? The question is this. Will this problem take 20 years?
It will take so much time, we won't be able to do the rest of the questions on the test.
Will it take 20 years?
Yeah.
It'll take 50 years.
50 years? But you know what? Let me tell you the limit here. You know, my policy is this. Whatever question I give you, my principle is every question could be done in about 5 minutes. If you're well prepared, about 3 minutes. In fact, many of them are very short. On this test, very short. Many of these ones you can actually do it in a minute. It's that short. Or maybe 2 or 3 minutes, but that's it. If a problem takes more than 5 minutes, that is not a question I will give you. But this question, I will give you this. I could give you a problem like this on the test. Now there are so many people in this class right now. Can anybody tell me what the answer to this question is? Can anybody tell me the answer to this question? Can anybody tell me the answer to this question?
Is it 14?
You're right, it is 14. Good. Very good. 14, you got it.
The first two
This
ones.
is the kind of question, which looks difficult, but this is what I call difficult looking. It looks difficult, and if you don't know what to do, it is difficult. Yes, it is. But if you really know, so that's why you need a good observation. So one of you gave me the answer, and the answer is actually 14. So equal to, and then dot, is equal to, and then is the answer 14, and the answer is 14 is correct. So if you got the answer 14, it is correct. So the answer is 14. So now, you still have a question here? Do you see why it's 14? I think many of you still have you're puzzled, right? You don't know how you get this 14, right? So this is how you approach a problem. When you have a problem like this, it's overwhelming, but calm down. I never give a problem which should take more than 5 minutes. That is, if you're well prepared and you are the best student, then you should be able to do every problem on the test within 5 minutes. I think 5 minutes, some of them it might take 5 minutes, but because you have to do the work, or you have to do some tedious work, some calculation, but generally 5 minutes is actually a long time. Most of the questions you might be done in 3 minutes or even 2 minutes. That's my side. Again, I don't like long, tedious problems. I hate those. So what is going on here? Well, let's see. When you look at this problem here, when you look at example 18, you have to scan the problem and see what's going on. So you have to make a careful observation. So here what you see is this. F of x is 5x minus 1, g of x is x squared. But note that there's a constant function out there. That one is, what's up? Why? Because this guy is he's a very simple guy. Now, when you look at this whole thing here, let's see, you have f, g, f, and then scan the entire problem here. Now note that there's h right here. H is right here. Hey, look at that. Isn't that a goodie? That's a goodie right there. Now, that means we have an input right here. We have that. And then when you do that, you get a number up to here. And then when you plug in a number to the h, what will that be? So basically, this is equal to this. Is equal to f of h of junk. So let me call that junk. The junk right there. What is junk? In this
Junk
case,
is going
the
to
junk
equal
is
3.
This junk right here, this guy right here, this guy, let me call that junk. We don't really care what that is. Why? Because there's a function h waiting right there. So therefore, what is that going to be? Yes, I think you said it. Yeah, you already said the answer. This is therefore equal to f of what? F of 3. And what is f of 3? That is equal to 5 times 3 and then minus 1. And that is equal to what? 14. 15 minus 1, which is 14, and that's it. This is it. So when you see a problem like this, don't be scared. Okay, don't be scared. But on the test, am I going to really give you questions like this? Yes, I will. I will give you a question like this. And if I give a question like this, it should take like 2 or 3 minutes. This one, literally 1 minute. Literally, you can just say the answer. But some of you will make a big mistake, and you will spend like 20 minutes, 30 minutes, and you will never get to the answer. So watch out. You have to remember, this semester, you met a very tricky teacher. Is that clear? So don't get mad at me, okay? But the general rule is all the problems on test, ideally, the problem can be done in about 5 minutes, or at least, if after spending 5 minutes, you should be close to the answer. But you know what? Never more than like 10 minutes. No, 5 minutes is little. It's a long time. On this test, none of the problems will take 5 minutes if you do it correctly. If you do it correctly, none of the problems on this test, on the third test, will be 5 minutes. Many of them will be 2 minutes, 3 minutes. That is, if you know what to do. That is, if you don't know, then you will spend 20 minutes, 30 minutes, and never get to the answer. That will happen on today's test. Okay, so you have to be careful here. So that's it. Okay, any question on example 17 and 18? Everybody understand this?
Capiche.
Claro?
Capiche.
Capiche.
Ish? Entiende? Okay, good. Okay, it's all claro, right? Okay, okay, so that's, now let's look at example 19 and 20. Okay, now that's an example. How about example 20? What is example 20 here? Example 20, well, what is this? Yeah, you can get that. And you can get this, example 20, and then example 20, we have this. We have f of 5. Well, yeah, this one, of course, is f of 5. So this one is f of 5, is f of 5. But by the way, when you do this problem here, you will find out that this one, after you do all this, you will see that this one actually comes with the answer will actually become 5. Okay, since we have more time, I'm not going to do this here. You will get 5. So this one will take about maybe I don't know after 2 minutes or 3 minutes. After a few minutes, you will get 5 at the end. So now the question is, if you plug in 6 here, are we going to get 6? Oh, we don't know. So that's the number 2 question. What is f compound f of x? You have to know how to simplify this. Then you get into complex fraction. And anyway, that's a practice on review on algebra, so do that. Okay, so I'm not going to do that. Why don't you do this on your own? Now let's look at example 21. Example 21 is this. Now here I give you a function, and then you know what? What is the question here? Now here the question is find functions g and h and k. The question is that you have to come up with the function. You have to come up with 3 functions, g, x, and k, such that g compound h compound k of x is equal to f of x. So I am not giving you the individual functions and you have to find the composition. I am giving you the composition, and you have to now find the individual functions. So do you understand what the question is? So here, you have to find these individual functions, g and h and k, such that their composition, g compound h compound k of x, will equal f of x. So once again, this is like a reverse problem. If you look at this, what is this? Let me just do it for you, x. If you plug in x here, and then plug in the function f here, we get this, f. We get square root of x to the 3rd power, and then plus 5. That is our function. So now how do you find this function g and h and k? Single operation functions, meaning functions which does one thing. Okay? Functions f and g or k, these are functions which does one thing. So I just call them single operation functions. Maybe add the 5 or take the square root or something, just does one thing. Okay, so if you now look into this function here, what does this function really do? When you plug in a function, when you plug number x here, what is the first thing we do here? If you plug in the value for x, what's the first thing? Well, we actually cube that number. And then once you cube that number, what does it do next? We add a 5. That's what we do next. But this is what I call a composition map. And then once we add a 5 to that number, what do we do? Then what we do, we actually take the square root. So if we open up the engine, open up the hood in the car, then this is actually what's happening inside. So let's say if we plug the number x equals, let's say 5, or x equals, let's say 7, then how do you get f of 7? To find f of 7, you have to plug x equals 7. Then to get that f of 7, you cube the number, and then add a 5, and then we take the square root. That's what we do. So inside this function, this is what we do. Now, let's look at the bottom. Let's look at this part right here. What is this part? This part here is the function where we add a 5. So the middle function, we actually add a 5. So first, we take the cube root, then we add a 5, and then what's the last thing we do? If this is x, then we take the square root of x. Not cube. Square root of x. That's what we do. And now, we want this g compound h compound k. K is the first one to go. That means it looks like this is k. This is what? H. And this is g. So now, therefore, let me write this down. Therefore, what is k of x? K of x is equal to this. And then what is h of x? H of x equals x plus 5. And then what is this? G of x. What is g of x? G of x is equal to square of x. Oh, is it time? Or you know what? I'm time. Looks like I'm done here. So let me just wrap this up. And so let me just wrap this up here. And so this will be, what is it? This will be x cubed. And then what? And then And then f of x will be square root of x. No, it's not. Sorry, it's not f of x. What is it? G of x. G of x will be what will be square root of x. And then you can check everything will fit. So I give you the composition, and now you have to find the individual functions. And again, this kind of diagram you'll see a few times. This is what I call a composition function. Okay, a composition diagram. Okay, anyway, time's up here, so I have to stop here. And so section 7.1 is now done. So today, don't forget to take the test. Test today. Test today. Okay, available, open at 11 a.m. It will be open very soon in a few minutes. Open at 11 a.m. 11 a.m. I think it's going to be